in the old jokes. Like you were there when the news happened. So true. Okay. Oh, that's just depressing. Plus, I'm getting like gray hairs in my beard. The other day, I fell asleep at like 7 p.m. on the couch. It was all I could do to stay awake till then. Okay, so in looking at virtual machines for last class, we were kind of talking about it right there at the end, and we were zipping through stuff. So initially, let's kind of give a definition. What is a virtual machine? So as you were doing this research, looking for stuff, what kind of categories do virtual machines fall into? How are they used? So before you can find positive and negative uses for them, you need to see how they're used. So what are some examples you found for how virtual machines are used?
You can use it to test out risky software.
Okay, so using tools like VMware Fusion, VMware Fusion is the Mac product from it. Parallels, there's several different open source ones. They allow you to, it basically generates an Intel-based computer in software, right? And then you can install stuff on it, and basically you can have a horrible virus, and it's self-contained inside of that shell. And then and a lot of work environments use these types of things, right? Why would that be? If you have, let's say you're at a job, and you physically have a computer in front of you, why would they have you use a virtual machine?
Because then the IT department there doesn't have to worry about a user getting a virus on their computer. They just get a virus on the virtual machine, and then they delete that one and give them the copy of that.
Yeah, I mean, this is easy peasy IT, right? So I'm sitting there, I'm on a local network, so I'm running my virtual machine. And usually the virtual machine would copy locally, so it would run reasonably fast. And then they can tune it to use most of your system resources, so it feels almost like it's a local machine, right? But then you call up IT and you say, hey, I have a problem. And IT says, oh, no problem. I don't care what your problem is. I'm just going to push you a new virtual machine. Here's what it's supposed to do. So whatever you've done to break it is now fixed, because now you have back to the original. So would that be an example of a good use of a virtual machine? Yeah, certainly. Users giving up a little bit of performance, not horrible. And in a business setting, not the end of the world. If you're playing video games, a virtual machine would probably be a very poor problem, which actually, would have been a reasonable answer to this question. Maybe, did anybody of you stumble upon something called WineX?
I know what it is.
Yep. So Wine is basically a virtualizer, right?
Yeah.
It's a virtual machine. So mostly it was used by the Linux folk to play PC games. And to a lesser extent, the Mac folk to play PC games, because Mac folk who play PC games are afraid of getting rashes and stuff like that. It's all on their mind. But, the idea was they were so desperate that they would use this emulator. Have any of you ever used WineX? It's terrible. You have to be really desperate. There was a couple of games that were very, very compatible with it, and they almost worked. I think that's the fairest statement I can make. Yeah.
The place I was at a couple years ago actually used it for legacy programs. So if they have compatibility issues,
That looks so sketch. He walks in, he's got sunglasses on, and there's about an 80% chance that campus safety is going to come in here after seeing that on the cameras. All right, so I'm sorry I interrupted you. This was more important.
it's fine. The place I was at a couple years back used virtual machines for legacy programs, so anything that wasn't compatible with 7. We used an XP virtual machine.
Yep. Yeah, great use, right? So a lot of places, they have a lot of money invested in some old software, and the old software does the job they needed to do, but it won't run. When they replaced the computers more recently, the computers shipped with Windows 7 or Windows 8, and the old crap won't run on it. So they have a couple of options, right? They can reinstall the old OSs on the new machines, but then maybe some of the new crap breaks. Or you virtualize the old stuff, which are probably going to be fairly low-powered programs because they were, even if it was considered a high-powered program back in the late 90s, a high-powered program in the late 90s is going to run real well on a smartphone today. You know, we've moved up in the world with technology a little bit. So again, a really good use of that stuff. So keep older software running for a longer period of time by running, you know, what we typically would not run as our primary OS as a secondary. To kind of piggyback off of that, when I used to program, I guess I say professionally, when I wrote software all day long, my machine that I had was a Mac Pro. Decked out, you know, I had 16 processors, well, 16 logical processors, whatever, and 32 gigs of RAM and all that stuff. And what I would do is I would devote half of the resources to the Mac, and I'd have a VMware Fusion running with Windows 7, Windows XP at the time, Windows XP at the time, installed on it. And I had two big 30-inch cinema displays. So one screen was my Mac, the other screen was my PC. And I could flip just back and forth between those two, you know, as needed, because I might be doing .NET development over here, and then maybe doing my back-end stuff on some tools that I prefer the Mac side for, or something like that, or the programs I liked were on the Mac side. So again, I basically turned one computer into two computers simultaneously with a virtual machine. But, you know, that computer had to have enough horsepower, right? So how many of you, you know, a good example would be on a laptop. How many of you have ever run a virtual machine on your laptop? Okay, what kind of experience do you typically have?
Sluggish.
Yeah. It slows down on one side, which then also, so your virtual machine is going to be sluggish, and then that also puts a drain on the other half, right? Because even though your laptop might be a very good laptop, you know, at best your laptop today is going to be a quad-core something. Maybe it has 16 gigs of RAM in it, in a laptop, something like that. So even if you devote half of your system resources, you're going to give two of the processors to the virtual machine, leaving you only with two. You're going to give half your RAM, so 8 gigs of RAM to the virtual machine, leaving you with 8. Those don't sound like bad machines, right? A dual-core something or other with 8 gigs of RAM. But it seems sluggish. Why? Related to what we've talked about in here.
It's using like way more memory than like anything else.
You got 8 gigs shared for each one. It's enough memory. Well, okay, there's certainly going to be some slowdown with any virtual machine because, I mean, you have an extra layer, right? That was what we were talking about last time. But why did it get so sluggish on a laptop?
Aren't you literally loading an OS into your memory?
Sure, you got enough memory for that.
It's like simulating a whole other computer is resource intensive.
Sure. How many of you have dual core? How many of you have a laptop with a dual core processor in it that has 8 gigs of RAM? 4 gigs of RAM. Let's go 4 gigs of RAM. A lot of you, right? Does it run at least reasonably well? Better than that virtual machine will run on a better computer?
But your resources aren't provided.
Which resources specifically? Virtual machine really drags because of one resource, and that's the hard drive. Okay? They're sharing the same hard drive. So if you want to have a machine that has two virtual machines, has a virtual machine running on it, and you want it to have maximum performance on that, your bottleneck's the hard drive. Put that virtual machine's drive on a different physical drive, and you'll see a substantial increase in performance. Because now you don't have two OSs vying for one resource. Okay? And where things get even worse on a laptop is I say often now. Now, you know, most laptops come with solid state drives, but let's roll back a couple of years. Laptops often have mechanical drives, and they also have smaller mechanical drives, 2.5 inch, which have lower RPMs, lower performance. They're less capable of handling multiple read-writes requests at the same time. All right, so we're pulling a yacht with a
Pinto.
Yeah, or a Civic. A Honda Civic or something, or with a bicycle. With a what?
A dinghy.
Oh, what? Pulling a yacht with the dinghy? Oh, that would be on the water. Yeah, that would probably be actually easier.
Normally you don't pull yachts on land.
Well, you could. I mean, every year when I had one. Every year when they had to take it out of the water here in Wisconsin, I used to have one at McKinley, and they had, yeah. Oh, that's a whole nother story. Oh, God. Ask me at lunch sometime. That's a good one.
Just casually blows off a story about his yacht. Rich people problems.
This was several years ago, about, I guess, 8 years ago. I bought a yacht on impulse. It's a very different person 8 years ago. All right, so, but it is a good story. If you're interested sometime, I'll tell it to you. But in any case, so that gets back to what we were talking about in here when we're trying to manage system resources, right? That hard drive is a really important system resource because we're using it a lot. We're using our RAM a lot, but every single time we launch an application, that hard drive's involved. Okay, a couple of classes ago, we talked about why some people do the smaller solid-state drive for their operating system and then do the larger, I could hold 3 terabyte drive for everything else, right? Well, part of it is things that you want to load fast, throw on the solid-state drive. Things that are just there for bulk storage, most of our completely legitimate 2.5 terabytes of audio music that I'm sure you all bought.
Of course.
Have you ever added up how much your music library would have cost you?
No.
And then just think about the ethics. I mean, I'm not blaming you, but I'm just saying. Has anybody actually done it?
Well, you gotta check.
Figured out what
Calculated the cost, but
you have?
I know I have not.
Oh,
How many songs you have?
yeah. Well, so who has the most songs in here? How many songs do we have? I won't put the name on the recording.
Somewhere around 350 gigs.
Well, that's an amount of storage. How many songs?
I don't know the number anymore.
Well, you can convert how many songs
It's like-
to
Well, I guess that's true. So we have a single song is what, about 4 megabytes? So 350 gigabytes. So times 1,024 is megabytes divided by 4. So 89,600 songs. How many songs are typically on a CD? 12. Okay. And and how much is a CD typically?
$20. 15.
15 bucks?
Yeah, it's-
So it's $112,000 worth of audio that you've stolen.
That's not counting the
It's not
terabyte of
stealing,
movies.
it's copyright infringement.
Yeah.
That way I can sleep at night.
Stealing sounds way worse.
Someone like let me borrow it.
Right, and that's true. So when you take the ethical computing class, my argument would be you haven't broken any laws until you listen to it.
Yeah.
That would be my argument.
I haven't listened to all those.
Before we listened to about $35,000 worth of that. This is coming from the guy who decided he didn't have enough money to fix his car. So, so I'm like, yeah, funny math, right? Okay.
It's legit.
All right. What else? What else do we find out about virtual machines? So certainly that shared resource, that hard drive, is important. So if any of you are looking at taking an older computer that seems sluggish and turning it into a newer feeling computer without buying a new computer, places to spend your money first are going to be, well, look at the RAM first. If you have an arbitrarily low number of RAM, 2 gigs today is probably too low. Probably minimal 4 gigs. But if you have at least 4 gigs, I probably wouldn't. I'd bump the hard drive first. And understand that better hard drive doesn't mean bigger hard drive. Better hard drive means faster hard drive. So that's why if you've ever been configuring a laptop, sometimes you'll see there, like on a laptop, you'll see an upgrade from the the 300 from the 500 gigabyte hard drive to the 300 gigabyte hard drive is a $175 upgrade. It's like, well, I almost cut my capacity in half. Why? Well, you have to look at the RPMs. Probably went from either 5,400 or 4,200 RPMs up to 7,200 RPMs. That kind of disappears with a solid state, right? So it's even grosser with a solid state. Solid state, you go from the 1 terabyte normal drive, you can upgrade for $500 to the 256 gigabyte solid state drive. So a quarter of the capacity for 3 times the price. 4 times the price probably, but whatever. I think it's coming down now, but still it's more expensive, right? It is more expensive. All right, what else? Anything else we found interesting with virtual machines?
Useful for running older software. Like,
Didn't he already say that?
did he?
Were you just not paying attention in class? What
Must
are you
have missed it.
What are you screwing around with over there?
Chapter 3.
Are you lying?
I was on chapter 2, but I thought we were still doing chapter 2 stuff.
So that was his whole. He had like a 3-minute talk about the place he used to work ran old software in a virtual machine.
It was briefly interrupted.
Well, right, which should have then at least brought his attention. He's like, well, what's going on?
I was doing the math to figure out my own music spending.
That was way before the music spending. I doubt very much you stumbled upon that logic before I brought it to your attention. All right, what else?
Well, a similar vein would be running software that other OSs, so being able to run Linux software, run Mac software.
Okay. All right. So those are good uses. What about bad uses? So we mentioned WineX, maybe as a bad use. What else?
Box, which you had posted about.
Yeah, so the Macintosh Blue Box. Why was that a bad use?
Because it separated it separated all your old applications from all your new applications and made it so that all of the old applications had to run in one little box.
Well, but isn't that what he said? You get to run your old stuff that won't run in your new computer. You know, in a virtual machine. I thought that was a good use of a virtual machine. So why was the Blue Box a bad idea? Just say this sentence. So why was it a bad idea? I assume several of you took that suggestion and used that in your paper. Blue Box. So why was it a bad idea? You could argue it was a bad idea. I'm not saying you're wrong. I didn't lie to you. The punchline is, why was it a bad idea? You got to be able to make that argument. Got nothing? Well, was it an example of Apple releasing a operating system prior to it being, I guess, let's say, ready for prime time? So you basically turned your relatively fast Apple computer into a very slow Apple computer running a new operating system that didn't have any software for it. So you emulated your old fast computer in a slow computer. Okay. On top of that, the Blue Box was kind of poorly written anyways, but punchline would be that you instead of running your old software until there was actually software that you were going to use available for the new OS, you just continued running your old operating system inside of the new operating system, creating a great slowdown.
Why wouldn't you just use the older computer with the old operating system
Why
on?
wouldn't you just use the newer computer with the old operating system on it and have even better performance? Okay, so the Blue Box created a problem rather than fixed a problem, right? So very few people had an adequate experience with the Blue Box. Okay, most people would have said, okay, well, my stuff ran a lot better before when I was running it natively on the computer rather than through a virtual machine. Okay, part of that was timing. So we look at today's computers, we already mentioned that our relatively fast computers today can adequately host a second operating system, right? You know, most of our laptops in here could stumble by with a second operating system. Well, when did OS X come out? Long time ago, 10, 12 years ago. Were computers a little bit slower then? Less RAM, slower hard drives, slower everything. Were our computers back then probably less capable of hosting a second operating system? So sure, the operating system was lighter weight than today. We can probably make the assumption that the OS X of today, or the OS, our operating systems today, are bulkier, more resource intensive, things like that, than our operating systems back then were, right? Sure. So it was easier to emulate OS 9, which is what the blue box was emulating, than it would be to emulate Windows 7 today. All right? But our resources haven't necessarily changed. Back then, you still had 7,200 RPM hard drives. So hard drives were basically the same speed. You still, you didn't have as much RAM, but you still had plenty of RAM. 2 or 4 gigabyte machines weren't uncalled, weren't unheard of. Punchline is you were trying to do just as much as we're doing today in terms of resource sharing. We mentioned a few minutes ago that our biggest problem with our virtual machines is the hard drive, right? That's probably your most noticeable slowdown, is sharing that hard drive with the host operating system. Host operating system being like, if you're running the Mac and emulating Windows, the Mac OS would be the host operating system. Okay? So it was a horrible end user experience. Well, that's a reason not to use a virtual machine, right? Kind of like when we talked about Flash on Android. It was a bad end user experience for all sorts of reasons. All right? So those are some things you could have said about the blue box. What else? What are some other examples of bad virtual machines? Go ahead.
This probably isn't a mainstream example, but I remember trying to run emulators on my iPod that were just awful, would crash all the time.
Okay.
Emulator is an example of virtual machine.
I think that's fair enough. Yeah. It's doing a translation in the middle. It's probably a relatively loose example of a virtual machine, because typically what emulators do, but I don't think it's an unfair example. So if we were to try to give a real strict example of a virtual machine, we'd have to say that it completely virtualizes an operating system. But we call the Java virtual machine a virtual machine all the time, and it doesn't completely virtualize an operating system. It just virtualizes the system calls, right? And translates between the Java system calls and the equivalent Windows or Mac or Linux system calls that the actual virtual machine was written for. So if that's an acceptable definition, certainly an emulator would be. If you're running a Nintendo emulator on your iPod Touch, your iPhone, or something like that, it's taking game ROMs, right, for these video games that were out, a zillion years ago, and it's converting them, the system calls for the little OS that ran on your Nintendo Entertainment System into equivalent system calls for your iPhone, something like that. So the reality is, though, those should actually, once it could be buggy, but it should be relatively fast. Okay, because we can probably imagine that Nintendo came out before most of you were born, right?
No.
The original NES?
Yeah, original NES.
I remember that.
85? Okay.
Oh,
You were born? Oh, it was before you were born. Yeah. I agree with you. So, the idea is, so chances are back then, that operating system, since all it did was take the game and show it on the screen. It was having to do less general purpose stuff than what we think of as our desktop operating systems today. So can we imagine that our phones today are probably substantially more powerful than a Nintendo Entertainment System was? Yeah. Did any of you ever, they stopped selling them. My Nintendo came with a robot.
Oh, you got the Rob?
Rob.
That was like a special edition.
That was like the original.
No, that was a special edition.
Special edition original. But they stopped selling it, right?
Because it was a special edition. It
Oh.
was like paired with the original. It was
Okay.
like a more expensive one that included like a different game, like a separate game.
Yeah, I'm trying to think of it. It was like a game where like pipes, and he knew how to play it. So you'd stick the remote into his little robot fingers, and he would sit there and play the...
It was like $50 more than the original.
Yeah, but I think it was only available when it first came out, right? Yeah, so the whole launch special edition thing, I guess. That was the invention of launch special editions. I might have still have... Well, actually, he probably burned down on the fire. I think my dad had a lot of that stuff in the basement of his dental office that burned down? This is years ago. It's a good question.
His teeth set on fire.
Nah, I mean, I think it was electrical shortage or something like that. But actually, it was really funny. So from an IT thing perspective, it's very interesting that the firefighters that came, I mean, the place just burned to the ground. It just completely roasted. Well, his server with all of his dental records and stuff like that were on the second floor. I mean, this was, I don't know, 15 years ago, 20 years ago. I mean, this was a while ago. Okay, when this happened, so we didn't have cloud storage and all this stuff. When the firefighters got there, first thing they did is some guy like scaled the side of the building and like cut into the side of it with an axe and pulled the server out. I mean, that was like they had a person dedicated to that job, so they must be used to dealing with businesses and things like that. So just find that interesting from but they were already they had like I think they had a tape backup every night that they put into a fire safe, so they had that. It was all charred and stuff, but. Yeah, the whole place cooked. Yeah. So I guess stuff happens. All right. Any other?
Syncing. So like, for example, I had a VirtualBox running in the Windows 10 technical preview, and I had Evernote on Mac OS and on the technical preview, and I would get a whole bunch of conflicts between syncing for those.
Syncing what?
The Evernote notes.
Oh, okay. So you had Evernote running on both of them, right? And so however Evernote does its syncing must have been the two protocols talking across the host operating systems were conflicting in some way. Okay. So certain applications might not play well with other applications that are on hosted virtual machines. Another example I'd given was AMD 64. Anybody look into that?
But I didn't quite understand what it was supposed to.
Like, were you talking about like 64-x86 or?
Yeah, the AMD 64 processors.
Or were you talking about AMD-V, like their virtualization thing?
Well, I think they might be both the same thing. I mean,
Because it said like AMD-V came out in 2006.
Oh no, so I'm talking about something much earlier than that.
Okay, yeah.
So the idea would be that when AMD first launched, they were one of the first companies to launch a 64-bit capable chip, but there weren't very many 64-bit operating systems. So the idea is like it was the cart way ahead of the horse. So it was kind of during a time where among technical people, this concept of 64-bit operating systems is going to be here tomorrow was a popular thing. In fact, if you were running Linux, a lot of people were building their own 64-bit kernels for Linux. Well, so AMD being kind of a mainstream CPU maker, they were a real competitor with Intel at the time. They came out with the AMD 64, way ahead of Intel's 64-bit processors, like years ahead. Not because Intel couldn't do it, but because Intel probably chose the correct path and said, why should we do it if it won't work for anybody's software? So AMD has this chip that comes out. You paid a higher price for their 64-bit processor, and it was a real hot commodity of people building their own machines. And then you install Windows, which didn't support the 64-bit chip natively. So the processor virtualized everything and reran it inside of a software core that ran it at 32 bits. So you added a virtualizer to your hardware CPU that converted everything, up converted everything to 64 bits with no performance increase because you had this extra layer you had to go through anyways. In fact, you probably had a performance decrease. The only place you'd really see functional improvements from the AMD 64 was if you were running it in a Linux kernel that was 64 bits. Now, this probably would have been okay had the 64-bit operating systems kind of started popping up, a year later or 6 months later or something like that. I think that they didn't really start popping up for like a decade. Let's see when the AMD 64 processor.
When I was reading it, it said that like Intel came out with a 64-bit processor first, but
It was called the Itanium. They're 60, but it was only for servers. It was not a consumer.
Oh, wasn't it?
Yeah.
Okay.
Does this tell us what year it came out? want to say it was like 2000 and
2000.
2000. Oh, 2001 is what this thing says on it. Oh no, this it had to be before this because this is the Opteron. This was their server class chip. I had a machine with dual Opterons on it. You were considered the cool kid if you had dual Opterons. So I'm talking about the 64 Athlons.
It's the first.
2000. Okay, fine. So we'll say year 2000, and then the first operating system that shipped with a 64-bit option. This wasn't mainstream. Was Vista. Windows Vista, you can get Vista 32 or Vista 64. And 64, nothing really worked. Go ahead.
My XP computer has 64-bit operating system.
Yeah, they came out with when they had NT4, they had an NT4 64-bit architecture for Itanium processors that was out during the same kind of time period. And then so there were some special like kernel mode ones for some of those operating systems, but I don't think Windows 95 or Windows XP ever shipped a consumer 64-bit version. I don't think you could buy it as a consumer. Did you buy it, or was this like an OEM thing that?
It was probably an OEM.
Okay, or maybe it was a very late software update. It's entirely possible. But as far as I'm aware, the first kind of consumer release of the choice was Vista versus 64-bit Vista. But 64-bit Vista at that point in time wasn't considered ready either, right? So 64-bit Vista, there was very few applications. In fact, did any of you who ran Windows Vista ever run the 64-bit version of Windows Vista? Okay. And then sometimes you had to launch the 32-bit version of Internet Explorer or a web browser. Why? That had nothing to do with Vista. With certain software product that was very, very, very often on websites back then didn't have a 64-bit version. It was Flash. So Flash shows its ugly face again, right? So Flash never wrote a 64-bit version. So back then, you had this latest, greatest, well, I use that in air quotes for Internet Explorer, but but really any browser on the system would have suffered from it. So any 64-bit web browser you had on Vista 64 would have not been sufficient for websites that had Flash content on it because you could not get the Flash plugin for a 64-bit browser. So you had to launch the 32-bit version of the browser in the 64-bit operating system. So let's just say, Vista, let's go Windows Vista. Launch year, launch date, whatever, 2007. All right, so at the earliest, we're going to say that AMD 64 was 7 years too early. At its earliest. I mean, that's best case. Okay, realistically, Windows 7 so 2009 was the consumer release. So almost a decade too early. Windows 7 shipped 64-bit by default. In fact, it was part of the install. I think the install let you choose whether you wanted 32 or 64, and I think it defaulted 64, didn't it? I sort of remember that, but in my old age, it's kind of going. Yeah, so I guess interesting stuff. But that would have been an example of virtualization done wrong, but not so much bad implementation, but bad timing. So having a 64-bit processor that could on board do some 32-bit stuff, perfectly acceptable for kind of a catch-all, right? The just-in-case type stuff. We have an example of that on the new OS for iOS. So iOS 9, one of these features is the what's it called? Like the data. It has something where it'll switch to your cellular data when Wi-Fi is crappy.
Yeah, Wi-Fi assist.
Yeah. Okay. So Wi-Fi assist, and so one of the things they're telling people is to turn that off if you often run into data cap problems on your data, because now you're going to sometimes, without your knowledge, you're going to be using some of your cellular data rather than your Wi-Fi. If you're sitting here at the school where we often have perfect internet, I'll tell you what, Eden, that's the network to be on. I rarely have problems with
I
Eden.
don't have problems with that.
Yeah, FalconNet, I've had some issues, but in any case, if you're on campus and you expect to be on the Wi-Fi, and all of a sudden you realize that you've been using 6 gigabytes a day as you're browsing Facebook for 9 straight hours, that might start getting to you. But I keep it on because I often watch movies and YouTube and stuff like that while I'm driving.
Seems legit.
Sometimes you hit Wi-Fi hotspots, but you want to be able to smoothly move between those. That's right. Yeah, I mean, sometimes you stop at the drive-thru, you allow you start your next movie strategically to buffer. Sometimes I set the cruise and get in the back. There was a true story. This was years ago. I think it was some people here on vacation from another country, and they had never been in a car with cruise control, and they thought it basically meant autopilot. And they were on the interstate. They set their cruise control. They went in the back and went to sleep. The car did not crash for 40 minutes. It was a straight interstate or something like that. Or it didn't horribly crash. I think it must have been bouncing off the guardrails and stuff like that, or kind of hugging the edge. But eventually they flipped. I think they all lived, but they flipped into a ditch I think they actually hit an overpass. Actually I think it was a horrible crash, but I think they lived because they were all in sleeping positions or something, and so they just kind of all fluttered up to the ceiling. I think they were all pretty okay, because I remember them getting interviewed and stuff like that, and it's oh, we thought it was driving itself. It's good for America. It was awesome. Okay. Any other examples? Virtual machines that we came up with? I just remember this one news story. I think they were on Good Morning America with Brian Gumbel, back when Brian Gumbel was Brian Gumbel.
And then they crash.
See, maybe when you guys are on your way to Raleigh, that's what happened. For all you know, the guy was catnapping in the back seat, thinking he was in his Google Drive car or something like that. All right, so let's at least introduce Chapter 3 here. So Chapter 3, we're going to dive in specifically to this idea of a process. And we've already kind of introduced this. Last couple of classes, or at least last class, I think I was referencing that I want you to start thinking about these things as data structures, right? So that's where we start connecting things to our kind of our programming world, where we have our generalistic data structures, but at the end of the day, we have to create these data models for representing the different types of animals that live in our operating systems, right? So we have this guy called a process that lives in there, and we're going to have to create a data model, a class, a data structure to represent the stuff we need to remember about a process. All right, because our operating system is obviously a giant piece of software, and we're going to be passing this guy around and all this jazz. All right, so what is a process? Specifically, we're going to spend a lot of time on process scheduling. What does it mean to schedule a process? So this deals with all sorts of resource sharing and things like that. So who gets access to the CPU and when and why, and are there different things with priority, things like that. How do we get onto the CPU? How do we leave the CPU? We had talked about that previously, I think, context switching. Did we mention that? We mentioned context switching? All right. I mean, I would have just mentioned it at the high level. So I'll quiz you on it, and then we'll find out if you get pissed. All right, so something we're going to spend quite a bit of time talking about is that act of a process leaving the ready queue, starting to run on the CPU, and then ultimately being kicked off the CPU, and what that means, how that works. Okay, because that this process data structure is going to be used for keeping track of where he left off, right? So every single time he gets CPU, he has to unpack his bags. When he's done with the CPU, he repacks his bags. Takes time. So if we spend too much time context switching, if a process doesn't get enough time on the CPU, then our applications are all going to feel sluggish, right? If he gets too much time on the CPU, well, if he doesn't spend enough time, all of our applications are going to feel sluggish. If he spends too much time on the CPU, only that one application is going to feel like it's working well, a la preemptive multitasking, where we talked about that with the old Mac OSs. Okay, so things were given too much CPU time to make the user ultra happy with whatever they were currently working on and completely unhappy, but later on, when they checked on their other stuff that was happening in the background. Okay, so again, this falls into this category from an operating system designer perspective, that we have all these thresholds that we need to think about. Okay, what's too much time? What's not enough time? What kind of programs is the user currently working on? Do certain things need more CPU time than others? Do I just treat everything the same? All these different variables we have to play with, and it's just a crapshoot. Kind of makes sense? So when you think about it from an operating system designer's perspective, it's a really hard problem to solve, because so much of it has to do with how human beings use their computers and how different groups of human beings use the computers. That's why we have, I think we at some level, we talked about the difference between our server operating systems and our desktop operating systems. So even though Windows 7 desktop, consumer, versus Windows 7 server, I think Windows 7 server was what, Windows 2008 server, I think was the actual. It was this Windows 7 kernel, but they called it Windows 2008 so they can charge you more or something. I think that's the way it works. But it was really the same kernel, but tuned for server kind of stuff, right? So taking those same threshold decisions and changing the model of how, how long something is on the CPU, what things do we keep in memory, not keep in memory, all those things, it changes depending on the type of task that computer's doing. Okay, how many of you are taking the human-computer interaction course? Or have taken it? Okay, so crazy boring course, right? Okay, no, but sometimes the boring courses are still important. Okay, so you think about how I totally agree with you. When I took a human-computer interaction course, it was the best chance of a nap I could find. Okay, but it's a dry subject, but it might be among the most important subjects. Understanding how people are going to use our applications. Okay, this translates through everything. When we're writing applications for smartphones or something like this, there's a skill set we're applying to it when we're writing the software and that kind of. And I realize we're out of time. Let me just finish up this comment. You can start packing. There's this skill set that we're applying to the problem, but we need to understand the problem and understand our solution first. That has little to do with programming. It's a lot more to do with understanding who our user is, how they're going to use the system, the use cases. That's what that software engineering class was all about, right? Understanding our problem and figuring out the problem. And a big chunk of that is how human beings are going to interact with our software. This all happens way before we ever write one line of code. So this is another example of where computer programming is not computer science. It's one little tiny piece of that puzzle. It's an important piece, but not any more important than these other surrounding things. All right? I will see everybody on Friday. Joel, no homework once again. 2 days in a row, exciting.